A section of garden railing is shown below. This section consists of 9 cylindrical bars labelled A to I, with a solid sphere attached to each of the centre of the top of each bar. The volume of each sphere, B to E, is 1.75 times the volume of the previous sphere. So it's getting bigger each time. What'd you say? 3/4 of, so if the first sphere had a volume of 100, you do 3/4 of that and add it on, or you'd multiply by 1.75. If the first one was 100, the second one would be 175, and then you get 175 and multiply by 1.75, and it'll keep getting bigger and bigger. You get what I'm saying? Now we need to figure out what the volume of the smallest sphere is. Would be a good start off. Oh, here we go. We already have it. 4/3 pi r cubed. 4/3 pi 3 cubed. Into the calculator for me, what you get? Change it to decimal for me. 36 pi multiplied by 100 equals 113. So 0.1, is that okay? I'll just look at the marking scheme here. So, all right, now here's what we're going to do now. Multiply that by 1.75 for me. So what's the next one? 197.925, yeah? Is it? That's what's saying in the marking scheme. Did they, it came to 92 on the money for you?
Yeah, it's just 92.
Did you use the original? Did you use the 36 pi and multiplied it? Yeah. So multiply that by 1.75. Yeah, well, there.
Oh,
yeah. Grand. Let's do the next one. Multiply by another 1.75.
3, 4, 6.
So I'm just going to cheat here because they're not rounding off, so I'm not going to round off either. Although we should eventually round off. It's actually, to be fair, lads, let's round off here. Lads, let's round off to 3 decimal places and leave it at that. Okay, so I'm going to start differentiate. I'm going to start different from the marking scheme now. You're multiplying it by 1.75 each time. So what's the next one? What? Formula, area of volume of a sphere. Multiply by another 1.75. 145, yeah. Multiply by another 1.75, please. 1060.754, excellent. And another 1.75, I believe. Oh, no. Add them all up to get a total, please. So you're adding up all of them combined. This is a 10 marker. A 10 marker for this. It's the hardest 10 marker we've done in this class today. What? Oh, there's both sides, is there? Does it tell you to go A to E, or does it tell you all of them? No, just yeah, I get what you're saying. It won't be times them by 2 either, Packer, because the middle one doesn't happen twice, only happens once. So you time 4 them by 2. Yeah. I get what you're thinking though. Just the first 5, aren't we? Add all 5 up, and what you get? 2324 centimeters squared. Yeah. What do you think of that question? Same as cubed, by the way, because it's volume. But yeah. Okay. The surface area of sphere E is 503 centimeters squared. Is sphere E the biggest one?
Yeah.
So the biggest sphere has a surface area of 503 centimeters squared. The height of the railing E is 1.2. So the sum of the heights of E bar and sphere E is 1.2. Find the height of bar E correct to 1 decimal place. Okay, yeah, exactly. We need to get the radius of the sphere. This red line here. Now, what is the formula for surface area of a sphere? Yeah, look at that, lads. Money. We're about to get paid here. Okay, what are we going to do with the r squared? 503 divided by Then let's find our R squared. You should probably take notes, guys. What do you get?
40.03.
40.03, square root that. 6.3 centimeters.
Yep.
Yeah. Now,
That's
see
the
that,
radius.
see that 1.2? Keyword,
Turn
centimeters.
Turn it.
120 centimeters. Okay, 120 centimeters. Now, I'm looking to get the height of the green bar here. See the green bar? We do need to double the radius. And when we double the radius, we get 12 point. Yeah, 120 minus 12.6 is 107.4 centimeters. So this is the next one's another 10 marker. The radius of each bar is 1 centimeter. The volume of bar A is 71.3 pi centimeters cubed. The heights A, B, C, D, and E form an arithmetic sequence. Find in centimeters the height of each bar. Now guys, you ready? So here's what we're going to do. We're going to do volume of a bar, otherwise known as volume of a cylinder. Why? Yeah, radius is 1, volume is this, and it's 71.3 pi. What cancels on both sides? What? The pi will cancel, won't they? All right, and we know the radius is 1, don't we?
Yeah.
So 1 squared is? So what's the height of the bar? All right, we got it. The height of the bar is 71.3 centimeters. Okay. All right, guys. Right. So here's what I'm thinking. This one here is 71.3, isn't it? And what was the tallest one again? No, we'll take away the 107.4. Now, guys, lads, arithmetic sequence works like this. It goes up the same difference every time. So that goes up D, 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 D. Now we're just talking about the height of the bar here for those of you who are just joining us. Not looking at anybody in particular. Now, so how many, what are you going to say? 71.3 plus 4D is 107.4. That's what we're looking for. Yes. I think that's pretty much what I'm about to do in a second. I'm literally going to do the same thing, just in algebra form. Now, it does want me to find the height of each bar. So that's the one thing I have to be aware of at the end. So I'm going to do exactly what you just told me to do. Bring over to 71.3 and take it away. And what do we get? 36.1 divided by 4, like you said. 0.025. Okay, I'll just leave it as that. Right, now here's what we're going to do. We're going to start off. Our first height was what? Right, add on D there for me. Yeah, let's just keep all the decimals this time. Let's not skimp on it. So when we add the D onto that, it's 80 point what? 325. Yeah. Next one, add on again. 89 point. Yeah. Add it on again. 98 point. And then when we add, we already know E to be what? 107.4. Now, lads, that is worth 10 marks, people. All right, guys, ready? There's a wall on each side, each section of the railing, as shown. So, and then as shown diagram, the distance from the wall to wall is 1.5 meters. The distance from the wall to bar A is 20 centimeters, and similarly, bar, I think it's I, is it? E, F, G, H, I. It's bar I is 20 centimeters away. All right, the radius of each bar is 1 centimeter, and the gap between each bar is identical. Find the size of the gap. Okay, have an idea. You ready for this? Change that to 150. Each blue line is worth how much? It's not worth 1. Why is it worth 2? Yeah. So how many 2s is there? 2, 2, 2, 2, 9. So do you agree that all the blue 2s add up to 18? The 220s, that's 58 centimeters used up, isn't it? And just give me 1 second. 150 take away 58? 92. And then how many gaps do we have in between? We have 1, 2, 3, 4, 5, 6, 7, 8. Divide that by 8. 11.5. You'll have 15 for that. Sphere on bar A and a sphere on bar B are joined together using a straight rod as shown. Mayhaps. We'll see in a second. Okay. And here's what we're going to do. Okay. Yeah, I know. So straight rod is shown, which is not drawn to scale. Find the length of the shorter rod that will join sphere A to sphere B. Now, this is tricky enough, right? So what I'm going to start off with is the blue part here. Actually, wait, no, I'm not going to do that. Here's what we're going to do. We're going to go back to sphere A. What was the radius of sphere A? Did they ever give it to us? The radius of sphere A was 3. So see that blue line? That's 3. Okay. Very first question. Can anybody tell me the volume of sphere B? Volume of B is 4/3 pi r cubed, and what you say it is again? 197. So just give me a sec. No, doesn't work that way. So what is it? 197.925. What I'd like to find out now would be the what's the R value that made that happen. So we're going to multiply it by 3, divided by 4, and cube root it. So we're going to get R cubed is 1.97925 multiplied by 3 divided by 4. And then I'm going to cube root the whole thing. Once you have an answer for that, let me know. What? Oh, we shouldn't have. It's underneath. Thank you for that. So what we get as the R value is what we might have rounded up or down, but we'll give it a go. What? It has to be bigger than 3 because it's a bigger one than 3. 3.615. Okay. Okay, we all good? Now, okay. Next thing I'm thinking is, I think I have it. All right, this is where the H1s have to make their money, basically. All right.
Yeah, but they're
it's I have the difference from actually. He's right. I actually think we do have this. See that red one? See that red one? I think we have it because it's actually the it's one here. Sorry, it's one here, and then the gap in between the green gap. So what's the green part plus 2? So what's the green part again? 11.5. So 11.5 plus 2. No, it's the center. There's a radius for each bar. The radius of the bar. Yeah. Sorry. It's 11.5 plus 2 is 13.5. So is everybody happy that's 13.5? Now, I think actually we might be lucky enough to get the gap here. So I have another idea here. If you indulge me with this, all right? So here's the next thing I'm going to look at. And this is going to be really, really, it's going to be a difficult one to pull off, all right? So you ready for this? Okay, so I'm just going to get rid of that 13.5 for a minute. I'm going to start over here, all right? And we know it's there. Now, here's what I'm thinking. How much longer is this bar compared to this bar? Oh, actually, we have an idea. Here's my idea. What's the height of the first bar? What's the height of the first bar? So would you all agree that the height from this point here, that's 71, right? And then add on a radius. Add on a radius. That's 74. Okay. Now, what's the height of the second bar in total? What? 80.325. Now, 80.325. Take the two of them away from each other, and it's 6.325. 6.325 is that yellow one there. Do you see that yellow bit? Add the radius. 3 points. Yeah, exactly. 3.615. Add them together, and what you get? What you get? 9.94, yeah. Let's Pythagoras' theorem, the 13.5 and the 9.94, and we're going to find out what is the length of the rods and the two radiuses added together. Everyone, let's keep going. Stay focused. What do we get when we put into Pythagoras' theorem? So Pythagoras' theorem tells us that this length is 16.76. And now we're going to take away our 3 and our 3.615. 10.1. And it says 10 in the solutions, but maybe we just... So, are you sure it's 16.76? Okay, we'll just park it there.